Hello children, we have started the lesson force and pressure and part 1 video has been already posted. I hope you have seen that video. With that previous knowledge, now let us move into the current content, which are buoyant force, pressure exerted by liquids and Pascal's law. Right? Now first topic is buoyant force. Say the word buoyant, it's a new word for you. And spelling also, don't get confused. Usually children make mistakes in this. B-U-O-Y, right? So when you pronounce it buoyant, children used to write B-U-Y-O, right? So don't get confused with that spelling. Be very clear. Buoyant force and buoyancy. I'll tell you a real-time example, children. I hope you would have you ever got drowned into water, or if you know swimming, you can recollect the experience, right? First, if you jump into water, what will happen to you? What you will experience? The first effect is first you will come up, right? While you are coming up, you can feel that something is pushing us upwards, right? If you don't know swimming or if you have not drowned into water, another example I tell you. If any object, if you put into water, right, first what will happen, let us take a ball as an example, right. So, take a ball as an example now. If the ball is just made to get into the water, submerge into the water, first what will happen, it will come up. Okay, how it is coming up? Right, something is pushing the ball, or the person who got drowned is, what is that pushing up? That is called as buoyant force, right? That is called as buoyant force, right? The force given up by the liquid on the bodies submerged into the water, right? But the force acts in the upward direction. Always buoyant force act in the upward direction. So let us learn the definition. The upward force exerted by a liquid. And this I had given in the bracket, children, fluid. I'll come to that afterwards. By a liquid is called as buoyant force. And this phenomena, this process of exhibiting the buoyant force is called as buoyancy. Okay. Now I had told here fluid, right? Fluids are nothing but anything that can flow, right? So we have three states of matter, basic three states. What are they? Solids, liquids and gases. In the solids are tightly packed, so they cannot flow from, flow means what? Move, right? Movement of molecules. It cannot move from one part to another part in the case of solids. But what about the other two cases, liquids and gases? Easily the molecules can transfer from one place to another, as they are loosely bound in the case of liquids and more loosely bound in the case of gases. One other example I can give you now for this. If you have incense sticks, right? In Tamil we say that to be udhuti, right? If we ignite this incense sticks, the incense sticks maybe you would have placed in puja room. But even when you are at hall or some other places, you can feel the smell, right? So from as it is a gas, it is a fume thing, when it is burned, right, when it is ignited, it travels through one place to another place. So this state of matter, which can flow from one place to another, liquids and gases, they are called fluids. Whatever we learn over here, this gets applied to gases also. So as we are very particular in this lesson about liquids, we are learning about liquids only. So, but you have to understand whatever property we are learning here, that applies for gases also, which you will learn in your higher classes, right? Right now this definition, can you understand? The upward force given up by the liquid is called as buoyant force, and the process and this phenomenon of exhibition of buoyant force is called as buoyancy. Okay, where do we use this buoyancy or buoyant force? That only decides whether an object can float on water, liquid, or it can sink in the liquid. Okay, so we have a condition over here. You wait, see here. First condition is that if the weight of a body is greater, the symbol I have given, greater symbol or less than symbol, right? Greater than the buoyant force, it will sink, right? Now, one example I will give you, right? Take one iron ball, one iron spherical ball, right? You have an imagination, right? In a bucket of water, if you are throwing one iron ball, what will happen? The buoyant force, every liquid will give some buoyant force, but the weight of the ball which is going to be dropped in the liquid is more than the buoyant force. So what will happen? This is stronger. The weight of the ball is stronger than the buoyant force. Always the stronger one will win. So which will go down? So even if this is pushing up, the ball will go down. That means what will happen? The iron ball will go into the water. Going into the water means what? It will sink. Right? Now, if the weight of the body is less than the buoyant force, it will float. Right? So, for example, take one rubber ball now. Right? In your imagination only, don't search for it now. Right? Now, take one rubber ball. What is that? You throw into water. Automatically, one upward force will come. What is its name? Buoyant force. Now, the buoyant force is more. The buoyant force is stronger than the weight of the ball. So, what will happen? The stronger one only will win. So, the buoyant force will lift the ball up. So, the ball will float. So, this is the condition, children. And here I am going to give you one work. Along with this consideration of weight, density also plays the matter here. Right? So that is not discussed in your book, that is for your self-evaluation. Google it or search through other books and find the answer for this. I will give you a question for this, right? A small pin you take, safety pin, right? If you throw that safety pin in water, in a tumbler of water, it will go down. Go down means what is the word? Sink. But big ship floats on water. How? Find the answer for this. Okay. So that is for your self-understanding. Now coming to the next topic, pressure exerted by liquids. So this pressure exerted by the liquids will have some properties. Right. So that are the properties we are going to see in this. Right. First one, pressure, the liquid will exert pressure not only on the bottom side, it also exerts pressure on the side walls. Right? So now we can say if you take a water bottle, right? Now I have a water bottle now. Right? Now I have some amount of water in it, right? Though you cannot think that the water is exhibiting pressure on the bottom part alone. No. Even on the sides, pressure will be given by the water. First say what is pressure? It is the force given on an area. So, water will exert some force on this side walls area also. So, that is your first property. Now, where we will apply this? We are going to learn. Wait. Next one is depth. Pressure depends on depth also. For this, we are going to do one activity now. Kindly watch. Now, I have a water bottle here, right? But without water. I have made 3 holes in this. See, at the different heights I have. Right now, I am going to pour water in it. You can try this at your home. Right? Right now, you see the holes what I have made are at different depths. One is at topmost part, one is at the middle, and one is at the bottom. Which is at the depth, deeper one, this is the one. Now I am going to pour water in it. Now observe through which hole the water comes with full pressure or less pressure. Okay, that is what we are going to see. Just watch it. I am going to hold these holes now. With my finger I am just closing the holes. Now I am going to leave it out, children, just watch. Right? Now see, this is the hole through which the water comes with great force. Right? Now what happens here? Okay. Now see here, children, through the bottommost hole only the water had flown out with greater pressure. That means what? As depth increases, deepness increases, pressure will increase. Force will increase. The liquid will exert more pressure at the deeper areas. Can you understand this? Now that is the concluding statement. See here, as depth increases, pressure also increases. So what are the properties we have learned now? Number one, liquid exerts pressure not only on the base but also on the side walls. Second one, as depth increases, pressure also increases. Now next one is pressure at bottom depends on the height of the liquid column. This property I had demonstrated you in the part 1 video, children. I had taken a balloon and I had fixed it under the water bottle, and as I pour water, the balloon got bulged up. That video you can watch and you can understand it, right? So what is that? As I pour water on the water bottle, the bulging of the balloon will be more. If you see that video, you can understand, children, the part 1 video, right? So that means what? As I pour more water on the water bottle, open water bottle, the bulging of the balloon will increase. That means what? Pressure at the bottom will increase as the depth of the liquid column increases. That is your third one. This is why, children, our dams are made. No, dams means, where we will store water. Right? There, where they will store water to greater heights. Once the respective height has been reached, what they will do? They will let out the water. You have seen in news and all, right? The level of water level of the dam will increase, and they release the shutter. The water will gush out. That means what? And as height of the water increases, it will exert pressure, right, at the bottom also and at the side walls also, as per the first point. If it exerts more and more pressure, what will happen? It can create more pressure on the walls and the water can damage the dams. So to avoid that, what will happen? What the people, engineers over there will do? They start to remove the water, extra water. So, and also, children, and what they will do, the dams will be constructed in such a way, the bottom also will be made stronger and the side walls also will be made stronger, because the water, as it goes deeper and deeper, the pressure will increase. No, the buoyant force will increase. So to withstand that buoyant force and buoyancy exhibited by the liquids, the bottom of the dam and the side walls of the dam has to be stronger. So this is the question given in your do you know, children? In that topic you can see. And also you have, scuba divers, children. Scuba divers means the one who will wear like fish-like suits dressed on their body, and they go down the marine, deep under the marine part to research on the marine organisms. They have like one special suit. Have you ever seen it, children? Right? In that, why do they wear that suit? Means no. As you go deeper, what I said here, as depth increases, pressure also will increase. The scuba divers will go down the water. As they go down deeper and deeper, depth increases. As depth increases, pressure also will increase. So their body should suit. The body should not get damaged due to the heavy pressure given by the water at the deeper areas. So to safeguard themselves by the buoyant force, from the buoyant pressure, what they will do, they will wear the special suit. Now the last point, children, at a given depth, liquids exert same pressure in all directions. So this I will demonstrate you with another water bottle, children. Now I have another water bottle, a small water bottle here. Here I have marked one round On that round I had made 3 holes, 1, 2 and 3 holes which are at the same height. Right? Now I am going to pour water in this. Now before I said I had made holes at different depth. Now you see at same depth I had made the holes. See this. See how the water is flowing out? The water is flowing out with same speed. If the water is at one particular height, at one same depth, the liquid this is the same depth, right? At one particular depth, here the water will exhibit, the liquid will exhibit same pressure in all directions. As depth increase or decrease only the pressure will vary. But at this point, the pressure at every point inside the liquid will be the same. So this also you should understand, children. So with this, now we are completing the pressure exerted by liquids. The next topic is Castel's law. The next topic is Pascal's law, children. Pascal's law. P-A-S-C-A-L apostrophe S law. Right? First let us learn the statement of this law. Pascal's law states that the pressure applied at any point of a liquid at rest in a closed system will be distributed equally through all directions of the liquid. First I will underline the key terms in this law, then I will explain it. Right? Pressure applied at any point of the liquid at rest, very important point, in a closed system will be distributed equally in all directions. See what a complex law in a very simple statement this great scientist has stated. This law finds so many applications in our daily life. In our day-to-day life, once I explain this, you can recollect, oh, this is what Pascal's law is. Right? So, as you learn this, then you apply this law in your daily life. Where and all we can observe these applications of Pascal's law. Right? First, we will say that pressure applied at any point of the liquid. Right? If you take a liquid in a container or in any vessel or something, right? If we apply pressure at one particular point, that pressure will be transformed through in all directions in equal amount. But what is the condition? The liquid should be at rest. So now for this I have one small activity which was given in your book only. I have a balloon here, but in your book it would have stated ball, right? Right. Now this balloon I have filled with quite a little amount of water. Right. Now I am going to prick this with pin. Right. Now you see the liquid is there. That is the fluid, a kind of fluid. Right. Now once I prick the ball, right, I am going to apply a pressure here, a force applied on one particular area. Now what will happen? Now the pressure will be exerted equally. Now you see, the holes I make, the liquids will come out equally in all directions. Shall we check it, children? So the liquid is here. 1, 2, 3. Now see. See, the water is gushing out. But at the holes, through all the holes, what is happening? The water is gushing out with the same force. See, children. Can you see it? Both the sides is coming up. Now I am applying pressure at one particular point. I had applied the pressure at one particular point. The water is gushing out in all the directions in equal pressure. So this is what Pascal's law is. Now, where and where we apply this Pascal's law? First one, hydraulic lift in automobile service stations. You can see car service stations in. You had seen most, right? There a heavy car will be there. In a very assault manner, they will lift the car with one small hydraulic jack, right? So they will keep that apparatus down the car and they will rotate one lever and the car will be lifted up. That is called as hydraulic lift, a simple hydraulic lift. Now advanced lifts would have come, right? What is that? Is hydraulic. That word I need to say usually. Hydraulic. That means it includes water. It includes fluids, right? Hydraulic. So it includes the movement of liquid. Now, that hydraulic lift inside it would have been working on the process of pressure applied on the liquid. What they will do as they move the lever, that is the pressure given on it. That pressure will go through that hydraulic lift and it will expand throughout the base of the car. That is what you would have seen now. That one advertisement also will come, right? A girl will repair the car, right? That tire changing advertisement. Recently it is coming, you can check it. In your daily life you would have seen it, right? The car will be lifted up through the complete base of the car. If they keep that hydraulic lift here, as they move the lever, the car will be lifted up so that they can service easily at the parts which are at the bottom, right? That means what? The liquid, we are giving a light pressure only, right? The pressure will be here, the bigger surface, flat surface is here, the car's bottom. The pressure given through the hydraulic lift will spread equally in all directions. So that's why even a heavier car can be lifted up. See children, a simple law used in our daily life. If you think that a car should be lifted up, how much human power or machine power will be needed, right? A quite interesting law, no? Then, automobile brake system, whatever it is, either it is a cycle or two-wheeler, right? Now, once we apply brake through our brake system, right, the wheels stops its movement. That means what? The brake shoes will be there now, near the wheels. We apply pressure here, slight pressure we apply, right? That travels through the wire and the brake shoes goes and stops the wheels. The place where the brake shoe touches the rim of the wheel, that alone won't get the pressure, the entire rim will get the pressure. So that means what? The pressure what we apply in our brake system will travel and throughout the wheel the pressure will be exerted. That's why the wheel gets stopped. So this is also an application of Castel's law. Then next one, hydraulic press. This you can see in even a small, the old items they will buy your newspapers and old items, iron items and all. They come at the end after arranging all the things and the paper will occupy a big space. So to what they do to avoid that occupying big space, what they will do, they will press it so that the paper will be at the uniform level, and to occupy the minimum space, what they will do, they have one press and they just keep the bundles and bundles of paper under the press. One strong press, the papers will be compressed. Even in factories they will use it for packaging. Just because one press, a flat surface of papers will be there, that pressure will be applied equally in all directions. So this is a very minimal application, children. So having this concept in your mind, in your daily life, please check where and how this law is applied. A very important law. It will be asked in 5 marks. So thorough well, understand well. Thank you.